Okay, so in this first example, we have a hypothetical XY flip-flop, and we have the table for it, the truth table, and we're supposed to come up with its characteristic equation and draw its state diagram and state table. So this will be a good example of what to do if you had the truth table, and if you had a circuit instead of a truth table, you could always look at the circuit and come up with the truth table. So what we want to do is come up with an expression for Q star or Q next, and we can do that by using a Carnot map. One way we can look at this truth table is to do it with 3 variables instead of just the 2. So I have X and Y and Q, that's the current state, and Q star, that's the next state. So I will put in all 8 possible values. And we know that when X and Y are both 0, the next output is to toggle. And so when X and Y are both 0, as they are in this first row, the output is going to be the complement of Q, or it would be 1 in the first instance and 0 in the second instance. When X is 0 and Y is 1, again we have a toggle. So toggle would just be the complement of Q. So in this third row here, Q is 0, so the complement would be 1. And in the fourth row, Q is 1, so the complement would be 0. When X is 1 and Y is 0, that's a set. And when we say set, we mean the output will be 1. And so for both of the next 2 rows, we'll have an output of 1. And then for the last 2 rows, when X and Y are both 1, that's a reset, so we would have an output of 0. So now we've got a truth table that has 3 variables, so we can do a Carnot map. And I will put XY on top and Q on the side, 0, 0, 0, 1, 1, 1, 1, 0, and 0, 1. And so 0, 0, 0 is 1. And where are my other ones? Okay, my next one, that's 0, 1, 0. That's right here. 1, 0, 0. 1, 0, 0. 1, 0, 1. And I think I got all the ones. Yes, I did. Okay, so now I want to find a cover for this. So a cover would mean get as few circles as possible and as big as possible. And so I can get that with this. And then I'll look to name these circles. I'll look and see what everything in the circle has in common. So this up and down one, in the up and down one, they both have X equal to 1 and Y equal to 0. So that is okay, hold on. There we go. Do y'all see my screen? Yes?
Yes. Can you hear me?
Yeah, I can hear you. So, but you do see my screen okay?
Yes, we can.
Okay, did it blink out for you for a minute?
It looked like OneNote closed.
Yeah,
and then
it
you
did.
opened it back up.
Yeah, okay.
But yeah, it showed whatever was behind there. So.
Yeah, okay. All right, so anyway, Q star, OneNote gives me fits. Okay, so Q star, in this vertical column, it has X equal to 1, so that'd be X, and Y equal to 0, and that's, so Y bar. And Q is both 0 and 1, so that's not in that expression. And then plus, and these two that I have circled there, they both have x equal to 0 and q equal to 0, and the y is different. So that would be x bar and q bar. So that is our characteristic equation right here. Just checking my notes. Yes. Okay, so this is the characteristic equation. All right, so we also are supposed to do a state diagram and state table. So the state is the different, any different output that you can have would be a state. Now this is just a single flip-flop, so it only has two possible states, a state of 1 and a state of 0. And I'm messing up again. Hold on. So when you draw a state diagram, you do something to represent each state, usually a circle. So I'll have a circle to represent each state, and I can call this state 1 and state 0. I could also give them names if I wanted to, so I could call it S1 and S0, and that's just the state of being in state 1 or being in state 0. And I have my inputs, I have both an X and a Y input. So I have different possibilities for ways to change states. So I can have 4 different possibilities for my inputs. I can have xy equals 0, 0. I can have xy equals 0, 1. I can have xy equals 1, 0. Or I can have xy equals 1, 1. Another way to represent these as inputs, so these are my inputs, I can also represent this 0, 0 as x bar, y bar. I can represent xy equals 0, 1 as x bar, y. I can represent xy equals 1, 0 as xy bar. And I can represent xy equals 1, 1 as xy. Sorry. xy. So these, this that I just circled right there, those are ways to represent my different inputs. So I want to see if I am in a given state and I have a particular inputs, do I stay in that state or do I go to the other state? Those are my only possibilities because I only have 2 states. So let's say I'm in state 1. So I'm in state 1. That means Q is currently 1. So if I'm in state 1 and I look and see what my possibilities are. If I'm in state 1 and xy is 0, 0, then my next state is 0. I go to the next state. So I will, if I have xy is 0, 0, I do this. And I can represent that by saying x bar, y bar. Now, if I am in state 1, meaning current Q is 1, and I get 0, 1, x equals 0 and y equals 1, so I am in state 1, so I'm going to circle here in my truth table. This is Q currently equal to 1. So where I circled, those lines right there, these represent being in state 1 because the Q tells you what state you're in. So if I am in state 1 and I get x equal to 0 and y equal to 1, I go to state 0. I go to the other state. So I can put that here as x bar y because once again, that would be going to state 0. So I'm going to put that on the arrow that's going over to state 0. Hold on a second. That's fine. No, I'm good. Okay, so now let's see what happens if we have xy equal to 1, 0. If I have xy equal to 1, 0, I stay in state 1. So I'll indicate that with an arrow like that. and x, y equals 1, 0, I do that with x, y bar. And then with x, y equaling 1, 1, that goes to 0, so I'll add that over here. Okay, so I took care of all 4 possibilities starting from state 1. Now I have to take care of all 4 possibilities starting from state 0. So that would be the remaining rows in my truth table. And the top row has that if I have x equals 0, y equals 0, and I'm in state 0, then I go to state 1. So that would be right here, and that was with x 0, y 0. And now if I'm in state 0, I have x equal to 0, y equals to 1, I go to state 1. Oh, wait, did I do that right? Yeah. So that was x equaling 0, y equaling 1, so that would be x bar y. Now, if x is 1 and y is 0, again, I go to state 1. So that's x, y bar. And if x is 1 and y is 1, I stay at state 0. So that's x, y. Okay, now, chances are that I can simplify this somehow because the expressions on top of the arrows going from one state to the other do not look like they are simplified. So the XY flip-flop is negative edge triggered. No, so this is not saying anything about when this occurs. So negative edge triggered would mean that it happens when the clock goes from 1 to 0. But nothing that I've done here tells us whether this is positive edge triggered or negative edge triggered. This is talking about the inputs and not the clock. So that's a really good observation. So this is talking about just when the inputs change. So let me show you on another problem what I mean by that. So if you look at this timing diagram right here, what I was talking about is when the inputs change. So that would be like on this top one when k changes from 1 to 0 or j changes from 1 to 0. But the edge triggering has to do with when the clock changes. And we don't put the clock on these state tables and state diagrams. So Grant, does that answer your question? Okay, good. All right. Okay, so now going back to this problem, let's see if we can simplify what we have up here. X, let's see. I hate OneNote. I might switch to another program. Okay, I'll just write small. All right, so I'm going to try to simplify this expression right here. I have x bar y bar plus x bar y. I am going to repeat this x bar y in the expression. Yeah, I can always add, x plus x is the same as x, so it doesn't change the value of the expression by adding that x bar y there. So from these first two, I can factor out an x bar, and then I have y bar plus y, plus from the second two, I can factor out a y, and I'm left with x bar plus x. Anything ORed to its complement is just 1, so this is x bar times 1 plus y times 1. And not y bar, just y. And so this equals x bar plus y. So I can simplify this top expression to simply x bar plus y. I could also use a Carnot map to simplify it. So the bottom expression, I'm expecting I would be able to do the same thing. So x bar y bar plus x bar y, and I'll just repeat that middle term, x bar y plus xy bar, except I don't think I have them in a good order. Let me change the order here. So let me do, let me put, I'm going to just change the order, I'm going to change the order up a little bit. So I'm going to put the x bar, y bar in the middle. So I'll have x bar y plus x bar, y bar, plus, and then copy the x bar, y bar over, plus x, y bar. Now from the first two, I can factor out an x bar, and I get y plus y bar. Plus from the second two, I can factor out a y bar, and I get x bar plus x. So that's just like in my first one. The y plus y bar is 1, and the x bar plus x is 1, and multiplying by 1 doesn't change anything. So this bottom expression can be simplified to x bar plus y bar. Or you could use a Carnot map to come up with it. Okay, so I think that was it for this first question. So y'all be thinking if you have any questions, anything you want me to explain better, and I'm going to stop this recording and save it and start a new recording.